Which of the following is the value of the limit of this expression squared x uh, minus 2 divided by x minus 2 as x goes to 4? In this type of expressions, we if this is a polynomial and if it is the power of function, power of x function, and x is far from 0, then we can directly put this 4 inside. So let's put this 4 inside first. So when you put this one, I mean, you should 4 and 4 here. What happens is we got square root 4 minus 2 over 4 minus 0. So 4 minus 4, which makes 0 over 0 case. So this is the indeterminate case. So indeterminate case means it can have a limit or not. And we don't know this one. Indeterminate case. In the indeterminate case, we try to do it with some simplification. So we seek for a simplification here, like square root of x minus 2, x minus 4. Okay, can we do some manipulation so that there will be some simplification? Let's see, square root of x minus 2 over x minus 4. Here, we want to get rid of the square root of x. So what we can do here is we can multiply both sides with square root of x plus 2. Now, when you do this, okay, let's do it here. So if you have a square root of x term, it's better we multiply both the denominator and the numerator with its conjugate. So what I mean by conjugate is this. If it is minus here, so it will be plus here. If it is plus, it will be minus. And then when we multiply these two, okay, let's look at what happens when you multiply these two. This is like a minus b times a plus b. So it will be equal to a squared plus b squared. So a squared minus b squared. So if you follow the same path here, so we will have square root of x squared minus 2 squared, which is x minus 4. And we have now limit as x goes to 4. We have x minus 4 divided by x minus 4 times x square root of x plus 2. Now, after this, we will look for a simplification. So all the things we do here now is to look for a simplification after some manipulation. So x minus 4 times square root of x plus 2. And here there will be the simplification here. You can say 1, 1. So then we end up with the limit of 1 over square root of x plus 4 as x goes to square root of x plus 2 as x goes to 4. And then here we can now put 4 inside, and it will make no problem. So we'll have our limit as 1 over 4. Which of the following is the value of this limit here? Now, if you have a polynomial here and a polynomial here, you can directly put 3 inside and see if there's a determined case or not. So when x goes to 3, 5 times, okay, 5x plus 1 equal to 2x plus 7 is, okay, you put 3 and 3 here. So you got 5 times 3 plus 1, and 5 times 2 times 7, so it will be 16 over 17. So there is no problem, the limit is this. So if you have 0 over 0 case, you try to do some simplification. If you have some number, non-zero number, but 0 here, then we say the limit does not exist. But anyway, if we have a number and not 0 over 0 case, we can directly say it's this value. This is 3 times 2, 6, sorry, 3 times 2, 6, it will be 6 times 7, it will be 13. So I didn't see it in the choices. Which of the following is the value of a for which the following function is continuous for all x? This question can be asked in the following way. For which of the following is continuous for all x, or we can say is continuous at x equal to 1. So if you make the graph of this function, we will see that the continuity of this function depends on the value of a, and the critical point here is x, only x equal to 1. Anyway, we will here, to get the value of a, we have to look at the limit at x equal to as x goes to 1. Then this is continuity, since f is continuous. So f is continuous. We want it to be continuous at x equal to 1. So which means the limit of, as x goes to 1, f of x should be equal to f of 1. So what is this? Now, if the function is taking, if the function behaving different at x equal to 1 and x is not 1, so if you're taking the limit when x goes to 1, you have to look at this case here. So it will give you the limit as x goes to 1, f of x, which is x squared minus 1 over x minus 2, x minus 1. Okay, we want it to be f of 1, and when you look at here, f of 1 from this piecewise defined function, it has to be equal to a. So we have some equality here, and then we will find the limit, and it will be equal to a. So what is the limit of this expression here? Okay, when you do that, when you put these here, you got like x, put 1 here, put 1 here. What you get is like 0 over 0 case, like 1 squared minus 1 divided by 1 minus 1, you say 0, 0. So it's just, we have 0 over 0 case. This is an indeterminate case. If in determinate case, we are trying to do some simplification. So we can do this one, x minus 1 times x plus 1 divided by x minus 1. And then after this simplification, we'll end up with the limit x goes to x plus 1 as x goes to 1. So then you can put here 1 inside, so it will be 1 plus 1, which is 2. So we end up with this 2. Here's the limit here, and this a has to be equal to 2 then. Now, what is the limit of this expression? Now, if we have polynomials, if we have a rational function here, so it means like the denominator is a polynomial, the denominator and numerator are polynomials. You can directly put 1 inside, substitute, then see what you have. Okay, now let's try to do it. Okay, we will try to put 1 for x. So then what we get here is 1 squared plus 1 minus 2 divided by 1 squared minus 3 times 1 plus 2, which is 0 over 0, which is indeterminate case. So indeterminate case means there might be a limit or not. Okay, the indeterminate case means this. So in this case, we try to do the simplification. We look for some simplifications, and since we have polynomials, we can do the factoring. This is the factoring of this part here will be, okay, let me write them one by one. The factoring of the numerator will be x plus 2 times x minus 1, and divided by the factoring of this will be x minus 2 times x minus 1. So now we will have some simplification here. So then the limit will be equal to the limit of x plus 2 over x minus 2 as x goes to 1. And now we can put this 1 here and see what happens. It will be 1 plus 2, 1 minus 2. So this will be equal to minus 3. So the limit will be equal to minus 3. So if you have 0 over 0 again, so you have to look for a further simplification. But anyway, we end up with a number, so there's no other step. Okay, which of the following is the value of this expression here? Okay, we have a polynomial here, we have a square root expression here, and as long as this, when you put 0 inside here, you got a number very far from 0, it's okay. And you can directly put, okay, in general, if you have square root here, you can put this 0, you can put this number. But the important thing is, like, when you put 0 here, it has to be like very far from 0. So it's square root 9 when you put 0, so there's no problem. This is because the right and left side of 0 is important, in the limit, and in substitution method, we should be safe of the left side and right side. Okay, then let's put it here. Okay, let's put 0 here and 0 here, and what happens is, okay, we get square root 0 plus 9 minus 3 divided by 0, which is square root 9 minus 3 divided by 0. So we will have 0 over 0 case. So this is an indeterminate case. So if it's an indeterminate case, it means there might be a limit or not. So we have to try to do some manipulation here, and algebraic manipulation. So if we have a square root here, and if we want to do simplification, we have to rationalize this expression here. What we can do here is try to multiply it with its conjugate. It means, like, if it is minus here, it will be plus 3. And since mathematically we don't want to change the result, so we have to do something which is worth 1, so that nothing will change mathematically. I mean, yes, as the value. Okay, then what is the limit of this expression? Now again, we come to this point here. So how can we multiply these two? So again, I want to remind you, a minus b times a plus b equal to a squared minus b squared, and which gives you this square root of x plus 2, then minus 3 squared. And when you try to do this one, you will end up with x, right? X plus 9 minus 9, so it will be equal to x. So now this part here is now x. Okay, let's do this. This one will be x, and here we have x times square root of x plus 9 plus 3, and there will be some simplification here. This is 1, this is 1. So what is the limit of 1 over square root x plus 9 plus 3 as x goes to 0? So the next thing is we have to put 0, and we will put 0 inside, substitute 0 for x, and then it will be 1 over square root 0 plus 9 plus 3, so 1 over 3 plus 3, which is 1 over 6. Okay, let's check if something is wrong. Oh, yes. No, hold on. No, nothing is wrong. So there will be simplifications and this, and it will be 1 over 6. So, okay, this is the answer here, 1 over 6 here. So I'm correcting it. Find the following limit if it exists. And it says find the limit when x goes, find the limit of f of x as x goes to 0, where f of x is this function here. And this is a piecewise defined function. As you see, this is a piecewise defined function. So it means it has different behaviors in different places. Okay, now here, if x is bigger than 0, it has the graph of, so for this part here, we'll have the graph of sine x plus 1. And for this part here, this is x bigger than 0, and this is x less than 0. We will have the graph of e to 2x minus 1. Now, I'm trying to do the graph here because we didn't show you the right limit and left limit issue. So we will make the graph and we will try to find the limit by using the graph here. Okay, now let's do the graphs and let's see if the function from left or from the left of 0 and the right of 0, does it come to the same point? Let's see, sine x plus 1x bigger than 0. So let's put here this x bigger than 0, this part, x is less than 0 is this part. Now sine x, remember the sine x graph? Sine x, okay, it takes the 0 value here and then goes up to sine x here. It goes up to 1 at pi over 2. So it makes 1. And then repeats its behavior. But here, this is sine equal, y is equal to sine x. But here, we want to make the y equal to sine x plus 1. So it will be 1 unit lifted. So if it is 1 unit lifted, it will come 1 here. And at pi over 2, it will come to 2. So it will be lifted 2 units up. So lifted 2 units up. So it will be, it was graph, well, its graph will look like this. But we will take x bigger than 0 part. So we will take this part here. Now we make the graph. Okay, it will start at 1. So it goes like this. Okay, it's just touching. Okay, not passing the x equal to 0. I mean the y equal to 0. It goes like this. So these are the pi over 2's. Okay, we're not interested in this part because we're interested only around 0. Now let's look at on the other side. Let's look at. Okay, let me write here. So y is equal to sine x plus 1. And now let's look at in the other part. Let's look at the e to 2x minus 1. E to x is this, and e to 2x, if you put the numbers in the table and see, this is just something like this. So you can say this is e squared to the x. Okay, now this is e to 2, a squared is bigger than e, so we'll a steeper function. And then we subtract 1, so it means we're taking this function here, e to 2x function, 1 unit down, so it has an asymptote, and now we shifted 1 unit down, so it will be minus 1 here, so it will be something like this. So when it is 0, it will come to 0. So it will be something like this. So because if you try to do x e to 2x minus 1, so you can put some values here, minus 1, 0, and you will get these here. Okay, we will have such graphs. So what we mean here is, what we need here is this part only, right? So we have this part only. Okay, we will put this part here. This is minus 1 here. Okay, it's minus 1 here. So it will go up to here. And then we don't put this dot here because here x is not equal to 0. So here we leave this one empty. Now we have the graph now, graph of f of x, and now it is we can directly look at the limit as x goes to 0. So this was the what's right here. This is the graph. So okay, it has an asymptote here. Okay. Now this is the graph of y equal to e to 2x plus 1. I'm sorry, minus 1. And this is the graph of y equal to sine x plus 1 on the right side. Now what's the limit of f of x as x goes to 0? Now we know we have to draw the line x equal to 0. We look at the right approach on the graph, and we try to approach from left to 0. So what happens is they don't meet, so we say the limit does not exist. You know, from the graph, we look at if they meet or not. Please, if you don't remember this, how to find the limits from the graph, please check out the video, check out the lecture. You will see it there in detail. Okay, let's look at this problem. Find the set of all points of discontinuities of the function whose graph is shown below. Okay, remember this. Remember, continuous means this. If you can make the graph of such thing as such a function like without lifting your finger, then this is continuous. It's continuous here. But if you, when you're making the graph, if you're lifting your pen, so this makes a discontinuity here. It's a discontinuity. And if you have something like also this, so there's this is a discontinuity here. Discontinuity. So discontinuities are the points where we lift our hand when graphing the function. So I can say discontinuities are the points Okay, now, so we were okay. We will look at we will not look at the endpoint here. We will not. So we don't have any idea about the left part of the function, the graph. So it's not given to us. So we will just look at this frame here only. Okay, this. So we will start, you know, by we will start here and let's put our pen on the graph, and then okay. We go here. So this is the first lift. So we lifted our pencil. Okay. So this makes the first continuity. First discontinuity. Now let's keep doing it. Okay, let's follow the graph. And now, okay, we lift our pencil here and we go this way. So this is the second discontinuity here. Now we follow it. So then we have to lift our pen, so it will make the third discontinuity. Now the graph ends here. So I'm not paying attention to those points here. Okay, no need to, because we don't know the behavior of the graph. I think it's given limited. We are given a window of the function, so we don't know the rest. But from this picture, from this graph, we can say the set of all these points are okay, -2 here. And when this is asked, we generally give the x values where the function is discontinuous, and there is this 1, 2, 3, 4, so 4. So it will be 4. Or you can say the function is discontinuous at x equal to -2, 2, and 4.